All right, good evening. Welcome back to Pre-Calculus. We are talking about complex numbers in polar form here. So one of the numbers we have to convert is 6 plus 6i. That seems reasonable enough. Okay, so what are we going to be working with here? We have 6 plus 6i. I always like to graph them first. Okay, so we have 6 plus 6i. So what we have here, 1, 2, 3, 4, 5, 6. So this is on the real axis, and then we have the imaginary. 1, 2, 3, 4, 5, 6. So here we have 6 plus 6i. That's what we're going to do is we're going to draw a little straight edge to the polar form. Okay, to the dot. We'll drop a perpendicular. And we have to figure out a couple of things. We have to figure out, well, what is this? What is the modulus? Okay, so what is this? Okay, so we're going to say, okay, well, that's going to be the square root, right? C is equal to, right, 6 squared plus 6 squared. So that's going to be C is equal to the square root of 36 plus 36. Tell you what, why don't we go ahead and factor 36 out of this, and we have 1 plus 1. Okay, and do it that way. Okay, because I know the square root of 36. And then 1 plus 1 would be 2. Okay, so the modulus we have here is 6 square root of 2. Okay, then we have to figure out this angle, because we want the polar form of this thing. We need that angle. Well, if I'm looking at this as a triangle, and I suggest that you do, okay, what I need you to do is figure out, like, we need a trigonometric ratio that relates the opposite side, the adjacent side, to this angle. What trigonometric function will do that? You say, oh yeah, tangent. So the tangent of theta would equal the opposite over the hypotenuse, or over the adjacent rather, sorry. 6 over 6, that's 1. So the tangent of theta is equal to 1. And now we're going to take the inverse tangent of 1. It's in the first quadrant. That's one of the reasons we drew the triangle, so that we take the inverse tangent. If we had a weird quadrant thing here, we would know which quadrant we're actually in. So theta is equal to pi over 4. Okay, that's one you should know, right? So to write this in the polar form, we have the modulus of z times the cosine of theta plus I sine of theta. All right. So we have 6 square roots of 2 times the cosine of pi over 4 plus I sine pi over 4. Okay. And we should have, that should be our value there. So the square root of pi over 4 is root 2 over 2. We're just going to get 6 times 2 over 2. We're just going to get 6. Okay, same thing with the sign. We're going to get plus 6i. Hey, isn't that what we started with? Sure is. So that's our answer for putting this thing into polar form, right? Just, this is exactly like polar coordinates too. Okay, this is not much of a stretch. And I got news for you. The next section, we're talking about something called vectors. They're going to be very similar to doing this. Okay, so it just builds on itself over and over and over again. So this is going to be 6 root 2, and then parentheses, and we have cosine. Oh, how about cosine of pi over 4, pi over 4 plus I sine pi over 4. I think you could use this as well. All the cool kids are saying it these days. Okay, so I think you could use S or CIS for doing the same thing, right? So that should do it for us. Double checking that. That looks good. All right, we got a green flag. We can keep going. Let's go one more. Oh, wait a minute. Sorry, part 2 of 2. There we go. So this is minus 6 minus 6i. Okay, so again, I'll draw it. So we have minus 6 minus 6i. All right. So we have to go 6 in a negative direction, so that's negative 6. And then we have 1, 2, 3, 4, 5, 6 in the negative direction, so we're going to be here. The modulus, that's going to be the same idea, right? We're just going to have 6 here, 6 here. So our modulus is going to be the square root of 6 squared plus 6 squared. This is going to be the square root of 72, which is equal to the square root of 36 times the square root of 2. So that's 6 root 2. So that's going to be okay. Now, check out the angle. So again, we have this angle here. We need an opposite over a hypotenuse or over an adjacent. They're both negative. So this is going to be theta is equal to the theta is equal to the tangent of theta, I should say, not theta is equal to. We'll say the tangent of theta is equal to the opposite, that's -6, over the adjacent, which is also -6. Wait a minute, tangent of theta equals 1. Didn't we say that was going to be pi over 4? That's why we draw the triangle. Because now I know it's in the third quadrant. So we have to figure out whose job is it to be pi over 4 in the third quadrant? So we have 1 pi over 4, 2 pi over 4, 3 pi over 4, 4 pi over 4, 5 pi over 4. Okay, we're just going around this thing like a clock. So theta, 5 pi over 4. So we're just going to say, okay, well, our polar form here is going to be 6 root 2. And then we have cosine 5 pi over 4 plus I sine of 5 pi over 4. And we'll know that the cosine is going to be negative because it's in the third quadrant, and the sine is going to be negative because it's in the third quadrant. And we'll get back to our original orientation here. So this guy here, okay, this is 6 root 2. So 6 root 2. How about 2? And then let's try it. Let's try cis. No, it didn't like cis. It put everything in there for us instead. So with cosine, we'll say this is 5 pi over 4. Okay. And then plus I sine. And again, we have 5 pi. Oops, pi up there. So 5 pi over 4. Okay, I tried to put cis in, it wouldn't let me. But if you're doing it on paper, that would be fine. You write cis. But cosine plus I sine, that's how we do it. Okay, and we'll check. Okay, hooray, we got 2 green flags, and we are ready to go on to the next one. Okay, thank you for tuning in. I will see you in the next video.